Hey explorers, today we've got a quick and easy experiment to help you answer one of life's many questions. Is it cold in here or is it just me? A thermometer is a tool that helps you measure how hot or cold something is. It can measure the temperature of a solution, an object, or even our environment, like the room we're in. There are different types of thermometers, like a pyrometer, which is attached to the furnace in your home and it helps you measure the ambient air temperature, or a cooking thermometer that helps you tell if your food's been cooked well enough to eat. There are infrared thermometers that can measure temperature at a distance, and many others, including mercury and digital thermometers like the one we use here in the lab. No lab would be complete without a really good thermometer, because temperature can be an important factor in experiments, often changing the way that materials interact with each other.
Yes!
Mercury thermometers are a glass or plastic tube which you can see inside to see the mercury, a metallic liquid that expands or contracts as the temperature rises or falls. Traditionally, mercury was widely used in thermometers, but is being phased out because of environmental concerns. In this episode, we're going to make our own thermometer at home, which is going to be modeled after a mercury thermometer, but is going to use safe materials. We are going to use items that you might have around the house right now. Then we can use our thermometer to measure the ambient temperature as we introduce it to hot and cold environments. For this experiment, the materials you'll need are a glass or plastic jar with a small opening, a cup of water, a cup of rubbing alcohol, modeling clay, food coloring, a clear or opaque straw, pen, paper, tape, and scissors. We're going to start by pouring our cup of water into our bottle. Then we need to measure 1 cup of rubbing alcohol. And we'll pour that into our bottle as well. Many thermometers used to be made with mercury as the liquid in them because it's very reactive to the temperature as it goes from hot to cold. But it's also toxic, which means it's dangerous to us humans. A lot of thermometers have now switched from mercury to kerosene, which is safer, but you should always tell an adult if you come in contact with liquid from a thermometer. Next, we're going to add food color into our bottle and swirl to combine. I'm going to be using a lot of blue, that way we can observe it more easily. Gonna put the lid on while I swirl it around, just so I don't make too much of a mess, as I tend to. Next, I'm going to set aside just a little bit of this liquid so we can add it to our straw after we get it all assembled. Next, we're going to get our modeling clay and straw ready. We only need enough modeling clay so it can form a nice seal around the opening of the bottle. So I'm just going to grab some, flatten it out into a little disc that can fit over the top of the bottle. Next, we just open up a small opening, use our straw to go right through it. Because plastic straws are bad for the environment, we found straws that naturally decompose. We're going to fit it onto our bottle. You want half of the straw in the bottle and half coming out the top. Then you want to use your modeling clay to make sure you get a good tight seal around the straw and the lid of the bottle. It's very important that all the air pressure is contained. This now looks like we've got a nice thick layer of modeling clay that's going to hold in all of that air pressure and make sure that our thermometer can work properly. Next, we carefully put our set aside amount of rubbing alcohol and water into the top portion of the straw. I'm going to use a dropper. You want the level of the liquid in the straw to be about halfway between the very top and the modeling clay. This way, when the temperature rises, you can see the liquid go up the straw, and when it lowers, it goes down the straw. Our modeling clay wasn't actually creating a good enough seal to hold in the air pressure. This is a real problem because you need your air pressure to be perfectly equalized in order for your thermometer to work. So we're going to use some saran wrap to try to seal off that air pressure a little bit better. Okay, so now we'll try dropping some more of our liquid into the top of the straw. And as long as the air pressure works and is sealed off, we should see it start coming out the top. All right, the biggest issue right now with our thermometer is that air is still moving in and out of the bottle. So I'm just adding a little bit of tape to our saran wrap to try to make sure we get the best seal that we possibly can. This is one of those experiments that goes to show that sometimes there's just a little trial and error. I'm gonna add a little more of our liquid and see where we get to.
Science! Fails.
Sometimes you need to just be able to improvise when things don't quite go as planned. We found out that our modeling clay was really soft, so it wasn't able to hold the air pressure quite so well. So adding some saran wrap and tape, we were able to get everything to stay in place, and now our liquid is staying in the straw for a really cool thermometer. So now we need a scale to measure it against. So we're going to take our piece of paper, put it next to our straw, and we'll cut right there. We've cut a square of paper that we can tape to our straw so we can see how hot or cold our environments are compared to our room temperature. So first what we're going to do is mark right there where our current level of liquid is to say that that is room temperature. And now all I need is a little bit of tape. There we go. Okay, grab a piece of tape. And we're going to line it up on our paper. And then we just need to attach it to our straw. So now we've got a thermometer with a small scale to tell us if an environment was hotter or colder than our lab, and it looks like it was made by MacGyver. When our thermometer is left somewhere, the heat energy in the air is conducted through the bottle to the liquid inside, causing the rubbing alcohol and water to either rise or lower through the straw, reacting to that temperature. As we've discussed in some of our other videos, temperature affects the volume, which is why the liquid rises and lowers in the straw. Now it's time to observe our thermometer in action.
Science!
When we place our thermometer in a freezer or outside in the Canadian winter, the molecules of the water get closer together or more dense, which causes the liquid to lower in the straw. Likewise, if we put our thermometer somewhere warm, like in the hot summer sun, the molecules in the liquid will get further apart, expand with less density, which pushes the liquid up the straw. And there we go. We have our very own thermometer that reacts to the ambient temperature and will help me figure out if I only need my lab coat or my lab winter coat. For more fun at-home experiments, subscribe to Clayton's Exploration Station on YouTube and social media. Plus, you can visit our website, explorationstation.net, to find worksheets on this experiment or anything else we've done in the lab. Now you stay warm and curious, explorers.
Clayton's Exploration Station.